assignment. So you'll notice in the PowerPoints and the videos that I've made so far, we focus a lot on just a few equations on the acids, the bases, and the redox reactions. Well, the Chapter 8 homework goes further than my videos go because the videos I'm trying to show the types of problems you're going to see on the exam. So it doesn't go as in-depth as the McGraw-Hill homework questions. But I wanted to go through them a little bit and explain some things as well. So you should be seeing your McGraw-Hill assignment. And you will get similar questions usually with different numbers involved. So I just wanted to go through a few of these questions for today. So here we have classify each of the following as either a Bronsted-Lowry acid, base, or amphiprotic. So what that means is it could be either an acid or a base. And we didn't talk about that at all in the PowerPoints. So looking for an acid, Bronsted-Lowry acid, let's go to the definition of a Bronsted-Lowry acid. If you remember from the last video and the PowerPoints as well, it's a species that donates a proton, so a proton donator. And then the base would be the proton or the H+ acceptor. So for this question, H3O+, since it has a proton on it, this is going to act as an acid because it has a proton, an H+, to donate. OH-, it's going to be a proton acceptor, so it's going to be a Bronsted-Lowry base. Now for water, water can be either. It can donate a proton or it can accept a proton. So since it can be either, it's that amphiprotic. I'm probably saying that word wrong, but so that's how you answer those questions. You look at, is it an acid, a base, or can it do both? Can it accept a proton or donate one? In that case, it would be the amphiprotic. All right, let's look at another question. Give it a second to pop up here. Okay, so for this one, write an equation for the reaction of HCl with water. Okay, so you need to fill in the boxes. So HCl, it would go in this first space here. I know this because of the AQ by it. So that AQ says it's aqueous, and HCl is going to be the aqueous one. So for HCl, we just write HCl, oops, lowercase l. And then where the L is, the liquid, that's where water is going to be because water is a liquid. You can see how you guys get frustrated with filling these in. Let's try this again. So we have HCl. Here's going to be water, H sub 2. O. So what's going to happen when we react HCl with water? Well, what's happening is HCl is going to be the acid, so it's going to donate a proton to the H2O, and then the Cl- is going to be paired up. So what would the answer be for this? We have H3, and then O, the plus sign. So the water is accepting a proton. Then we're going to have the chlorine minus by itself. So that's how that's going to look. So the water in this case is acting as a proton acceptor. The HCl, being the acid, is acting as a proton donor. Let's look at another one. Write the formula of the conjugate base of HI. So HI is an acid. Let me show you a little bit better here. Let's go to the whiteboard so we can see exactly what conjugate base means. All right. So you should be able to see the whiteboard ahead of you. So HI was the acid that they gave us. So let's write HI. So when HI dissociates, what it's going to do is it's going to, if we react it with water, much like the previous one, this similar thing is going to happen. We're going to have this hydrogen being a proton being donated to the H2O. So we're going to get H3O plus, and then the iodine portion is going to be left by itself. Now iodine is a halogen, so it always forms a -1. So it's going to be I -1. So in this case, the I -1 is the conjugate base. So this is the conjugate acid base pair, HI going to I-. Right, let's look at the next problem. So we have share the screen with you here. So the answer would be I- in this case. Let's look at number 4. I know there's a problem they do in here that I didn't give you an equation for, so I wanted to show that. And I know you can find it in a book with the assigned reading as well. So here it's asking you to identify the conjugate acid-base pairs in each of the following chemical equations. So we kind of looked at that a second ago. So in this one, we have NH4 plus and then a cyanide ion. Okay, so I'm going to go back to the whiteboard so we can label these. So I have the equation was NH4 plus Cn minus going to HCN plus NH3. Okay, so it asked for the conjugate acid-base pairs. And expand this. All right, so the conjugate acid-base pairs. Well, first we need to identify what's the acid and what's the base on the reactant side. So the acid is going to be this ammonium ion. So this is the acid. The base is going to be the one with the negative charge. Because if it has a negative charge, that means it's going to be a proton acceptor, and that's the definition of a base, a proton acceptor. So when they're asking for the conjugate acid-base pairs, you want to start with the acid and say, okay, here's my acid. What is its resulting conjugate base? So what is NH4 plus changing into when it loses a proton? Well, when NH4 plus changes and loses a proton, it becomes NH3. So this is my first conjugate acid-base pair. It'll be NH4 plus going to NH3. That's the conjugate base it's forming. Now the next pair, we're going to look at the base itself. So the base is Cn minus. Bases are proton acceptors. So when Cn minus gains a proton, what does it turn into? It turns into HCN. So my next pair, I have my base, Cn minus, forming HCN. So this is my base, and that's its conjugate acid. This is my acid, and that's forming that conjugate base. Okay, so these are the pairs that they're looking for in that problem. So let's go back and answer the question. So it said, identify the conjugate acid-base pairs. And we just said NH4 plus is forming NH3. Conjugate acid, the acid is forming that conjugate base. Cn minus, the base, is forming HCN, that conjugate acid. Okay, so that would be the pairs. So looking at the next one, we have CO3 2 minus, that's the base, and it's gaining a proton to become HCO3 minus. So this would be the first pair. HCl, so that's hydrochloric acid. That's the acid. When it loses a proton, when it loses that H plus, it becomes Cl minus. So we have HCl going to become Cl minus. That would be the two pairs in that equation. So that's how you're going to answer that type. All right. Let's look at number 5. I believe this was the one that had the equation in the book, but not one that I gave to you because you won't get one like it on. Nope, this is stronger weak acids. Okay, so to identify stronger weak acids, you just need to memorize them. Essentially, it's kind of hard to know if it's a strong or weak acid unless they give you a equilibrium equation, because when we looked at the PowerPoints, the definition of a strong acid was that it would fully dissociate, and you can only see that with a reaction equation. So this would be something you would just have to look up. Off the top of my head, these are all weak acids because they're polyprotic. What I mean by polyprotic is they have more than one hydrogen, and that's usually if they have more than one hydrogen, they're weak. So I would say all of these would be weak. That's just off the top of my head. So lucky you got them right. So that's something you just look up in your book. No real trick to that. So I want to get to the hard one. Okay, so this is the one that I wanted to look at because I didn't give you an equation to solve for this. So in this case, it's asking you to calculate the H3O plus concentration, so the concentration of the protons of a solution, and then the molarity that they give you is the molarity of the OH minus ions, and we haven't looked at that before. So I'm going to go ahead and go to the whiteboard and show you how to work through a problem like this. Okay, so let me share the whiteboard with you and we'll try this out. All right, so I'm going to go ahead and clear what's on it and we'll do another one here. All right, so the problem we were just looking at, the question was asking for, let me get my pen out. The concentration of the H3O plus ions. That was the question. They're saying, what is the concentration? Okay, and the only equation that I've given you for concentration, you need the pH to figure out. Okay, so I haven't given you this one. The equation you're going to be using for this is KEQ, so it's going to be 1.0 times 10 to the negative 14 is equal to the concentration of H3O plus times the concentration of OH minus. Okay, so in this case, the question is asking us to solve for H3O plus. So we want to get that by itself. And they actually gave us the concentration of the OH minus ions. So OH minus, my hydroxide ions, they said the concentration was 2.2 times 10 to the negative 9th molar. Okay, so we have the OH minus concentration. So when I rearrange this to solve for H3O plus, how I'm going to do that is I want to get rid of that OH minus. I want to get it on the other side of the equation. So to do that, I'm going to divide both sides by OH minus. That way it cancels out on this side of the equation. And what I get is H3O plus by itself. So to solve for the concentration of the protons, I'm going to take 1.0 times 10 to the negative 14th, and I'm going to divide that by my OH minus, which is 2.2 times 10 to the negative 9th. Since both of these are molarities, the H3O plus is going to come out in molar. So let's see, we have 1.0, 10 to the negative 14th. We're going to divide that by 2.2 times 10 to the negative 9th. So entering that into my calculator, oh geez, I get, how many sig figs are we looking at? I think just the 2, it looks like. So 4.5 times 10 to the, and it's negative 1, 2, 3, 4, 5, 6. I get negative 6. That's how you do those types of problems using this equation here. I think they only have 1 or 2 on the homework. You won't need this equation for the exam or for the final, just for the homework. All right, so let's go back and look at homework. So you would enter that answer, 4.5 times 10 to the, what is it, negative 6, did we say? And then you would enter that answer. All right. Moving right along here, skip and go to number 8 just to see what that is. So here it's the same type of question, asking you to solve for the concentration of the protons, but this time they're giving you the pH. Okay, so they're saying the pH is 6.08. So you do have this equation on your equation sheet, and you will need to know how to do one like this for the exam, and probably the final as well. So for this one, we're using the pH equation. So they're asking you to solve for H3O plus. That's the question mark. And they give you the pH. So pH is 6.08. So we're just using this equation here, 10 to the negative pH. So you would plug in negative 6.08 up here. So for me, on my calculator, that's the second log button. And then I do a negative 6.08. I get 8.32. How many sig figs are we looking at? It looks like 3. 8.32 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. Negative 7th is what I'm getting. And since it's concentration, it's a capital M for molarity. All right. I'm going to go ahead and skip to, let's try 13. See what this asks us. I just wanted to show a couple problems like they're doing on the homework because they're a little more in depth than what we've been doing. So calculate the pH of a solution, and then they give us the concentration. Okay, so 1.6 times 10 to the negative 6. So let's go ahead and work that one out. So this time they gave us the concentration of the H3O plus. They said it was 1.6 times 10 to the negative 6 molar, and they're asking for pH. So we want to use the equation where pH is equal to negative log, and then we'll enter the concentration of the H3O plus ions after that. So negative log, and in this case, it is 1.6 to the negative 6. So entering that into the calculator, I get, looks like 2 sig figs, so I'm going to round up to 5.8 is the pH. So now that I know the pH is 5.8, I can tell if it's acidic or basic. And remember, for acidic and basic, we have that scale from 0 to 14. So if it's less than 7, it's acidic, and if it's greater than 7, it's basic. So in this case, we have acidic. All right, well, that pretty much sums up chapter